All jobs in the nightly reporting box vanished after a maintenance window, triggering a 3 a.m. page. The engineer assumed delete box only removes the container, but it recursively deletes every job inside, with no undo. Let's break down JIL introduction and syntax, how it works, and the exact mistake behind that failure. JIL stands for Job Information Language. It's like filling out a form for each job: name, command, machine, schedule. You write JIL in text files and submit them via the JIL command. There are two ways to submit JIL: interactive mode for quick tests and script mode for production. Always use script files stored in Git. Every change is tracked. Here's the interactive method on top and the script method below. The syntax check flag is a lifesaver. It validates without making changes. Every job starts with a subcommand like insert job, then attributes. Keywords are case-insensitive, but job names and machine names are case-sensitive, a common gotcha. Notice the quotes around the command with spaces and the condition attribute that chains jobs. Also note the comments. They're great for documentation. These are the most common subcommands. Delete box is the most dangerous. It recursively deletes all jobs inside the box with no confirmation. Notice that update job only needs the attributes you're changing. And delete box deletes the box and all children. Use with extreme caution. The autorep command with Q flag is your best friend. It dumps the exact JIL definition of any job, which you can redirect to a file for backup or editing. Use the wildcard % to dump all jobs in a box. Always run this before any delete operation. It's your safety net. Treat JIL files like code. Version control, code reviews, CI checks. Always set alarm if fail so failures trigger alerts, and validate syntax before importing. This is a production-ready JIL file with version header, alarms, and a condition dependency. Notice the max run alarm to detect hung jobs. Before running any JIL, verify your user permissions and network connectivity. Most JIL errors are actually access or network issues. Run these commands to confirm you have access and the event server is reachable. If telnet hangs, it's a firewall issue. JIL supports variables with double % syntax. Define a variable once and reference it in all jobs, makes environment promotion a breeze. The variable app_home is defined once, then used in the job command. When you promote to UAT, just change the variable value, not every job. For simple storage service paths, use JIL macros. Define the base path once, reference it everywhere. When the storage team moves buckets, you change one line. The command uses macros for both the base path and the date. No hard-coded strings. If the bucket changes, update the macro definition. If your job targets an elastic compute cloud instance, add a condition to verify it's running. This avoids wasting a run cycle on a dead instance. The macro EC2 running checks the instance state. The job only runs if the condition is true, otherwise it's skipped cleanly. If your pipeline depends on a Lambda, account for cold starts. Use a trigger job that invokes the Lambda, then a poll job that waits for completion with a realistic timeout. The trigger invokes the Lambda, the poll job waits with a sleep to cover cold start, and the processing job checks the result. This decouples the delay from the dependency chain. Always validate network connectivity to your target before the main command runs. Use a condition that checks DNS, port, or Amazon Web Services API status. This job checks the elastic compute cloud instance status before proceeding. If the instance is not running, the job fails early instead of wasting a run cycle. When running jobs in containers, the command field must use kubectl or Docker commands. Use macros for image tags to avoid hardcoding and check pod status before proceeding. This job uses a variable for the image tag and a condition to check pod status. Always use dynamic tags to avoid stale images. This is the same issue we highlighted at the start. Here's exactly why that happened. The engineer assumed delete box only removes the box container, but it recursively deletes all child jobs. The box name was off by 1 character, and there was no confirmation prompt. The engineer assumed delete box removes only the container box, leaving child jobs untouched. But DeleteBox is recursive. It deletes the box and all jobs inside it immediately, with no confirmation prompt. The fix was to restore from a backup taken earlier. The engineer had run autorep JIL nightly reporting %q backup, JIL, before maintenance. Re-importing that file restored all jobs and the box, always backup before any delete operation. This is the exact command from the incident. DeleteBox removes the box and all children. Use deleteJob on the box name if you want to keep the children as standalone jobs. If your command has spaces and you don't quote it, JIL only takes the first token. The job runs opt scripts run and ignores report, sh, causing a command not found error. Interactive mode leaves no record. If something goes wrong, you can't trace what was changed. Always use script files stored in Git. Job names are case-sensitive. Daily report and daily report are different jobs. Always use consistent casing and verify with autorep. The DeleteBox behavior described is consistent across AutoSys R11.3 and later, but in R12.0 plus the autorep, Q output includes a slash generated by autorep/header that must be removed before re-importing. Also, JIL Syntax Check is available only in R11.3.6 and above. Earlier versions require a dry run with a dummy instance. The article mentions backing up with autorep, Q, but doesn't show the full command to capture a box and all its children. Use this snippet to create a time-stamped backup file that can be re-imported verbatim. When you delete box, any external jobs that have conditions referencing jobs inside the box will remain in the database with broken dependencies. Those jobs will stay in inactive or waiting state indefinitely. Always run autorep JIL box name, Q first to identify downstream dependents, and update or delete them before removing the box. When debugging JIL issues, start with a syntax check. Then verify the job exists with autorep. Use head and tail to inspect specific lines in your JIL file. Let's run through some common interview questions. What is JIL? Declarative language for AutoSys jobs. Difference between deleteJob and DeleteBox. DeleteJob removes single job, DeleteBox removes box and children. How to view JIL definition? Autorep JIL job name Q. And a few frequently asked questions. What does JIL stand for? Job information language. How to import a JIL file? JIL file, JIL. Is there an undo for DeleteBox? No, only restore from backup. To recap, JIL is powerful but unforgiving. Always use script files, validate syntax, and never run DeleteBox without a backup. Treat JIL like code, version control, review, and test. Ready to go deeper? Up next, JIL job types. CMD, box and file watcher, then JIL attributes complete reference, then JIL insert job update job delete job. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.